Okay, and here we're supposed to obtain an expression for the voltage gain. Voltage gain is defined as VO over VS, or V out over V source for this circuit. Okay, so remember our rules. VP has to equal VN, and IP has to equal IN, has to equal 0. All right, so let's look first at IP. Okay, so IP. So current is always beginning voltage minus ending voltage over resistance. So IP equals VS minus VN over RS. And we know that has to equal 0. Well, if we multiply both sides by RS, this tells us that VS has to equal VN, which tells us, actually this was IP, right? Yeah, sorry, this was VP. It doesn't really matter because of our next step. So this was VS minus VP because the plus was down there. So VS has to equal VP, but VP has to equal VN. So VS has to equal VP, which equals VN. So those things all have to be true. Okay, so now I am going to use this right here. And since let's see, yeah, okay, so looking at this stretch right here, if we look at that and just kind of line it up, this is V out, this is VO prime, so that's the voltage right as you come out of the op amp. This is R3, this is RL. So I can use voltage division, and just like we did on the previous problem, so our total voltage change here is VO prime. So VO has to equal VO prime times the resistance between ground and VO, which is RL, over the sum of the two resistances, which is RL plus R3. Alright, and then let's see, what did I do here? I believe I did nodal analysis. That's what it looks like I did. Yeah, except looks like I got my VS's and VN's backwards, but it doesn't matter because they're all the same. Okay, so I did nodal analysis, and using this node VN and this node VP. But remember, VN and VP are both VS. So I'm going to start with my top node here, which is VN, and I'm going to write all my currents coming out of VN. So the voltage here minus the voltage at the other end of the resistor over the resistance, and I'm going to add all of those currents up, and they will equal 0. So VN, which is VS, so going this way, VS minus 0 over R1, plus, now going up, VS minus VO prime, because that's the voltage on the other side, over R2. And then my other current is 0, because IN is 0. So I could put a plus 0 if I want, and that has to equal 0. Okay, now I'll write my equation for my other node, VP, here. So VP, which is VS, so VS, well, this one is just going to give us 0. So I'm not going to do that. So I won't do that node. So that one, I mean, I could do it, but it's just going to give me a bunch of zeros. So VS over VS, VS minus VS over RS, plus 0 equals 0. So that one doesn't give us anything. So then I need to do this last node here, VO prime. So VO prime, going this direction, VO prime minus VS over R2. What did I do here? Hold on. Okay, so actually, I don't think I need to do this, because what I am looking for, what my problem is asking me for, is for an expression for this voltage gain. So for VO over VS. And everything else is a constant. And since I have VS in here, in this one equation that I already have, and I have VO given in terms of VO prime that I can plug in over here, then I do not need to do another equation. And I wasn't quite sure how I was going to do that, because I didn't know how to do the current, going back to the op amp. So so good. So I don't have to do that. So I'll take this equation right here. So I have VS over R1 plus, now I'll just break this up into two pieces, VS over R2 minus VO prime over R2 equals 0. And now if I look at I can solve for VO prime right here. So this tells me that VO prime equals VO times RL plus R3 over RL. So I can plug that in for VO prime. So VS over R1 plus VS over R2 minus VO times RL plus R3 over RL. So that's this part right here. And then I also have this R2 right there. R2 equals 0. Okay, now I'm looking for V out over VS. Probably should, let's see. So I'll get a common denominator here for these. So my common denominator would be R1, R2. So multiply this one by R2 over R2. Multiply this one by R1 over R1. So I get VS R2 over R1 R2 plus VS R1 over R1 R2. And I'll take this to the other side, VO RL plus R3 over RL R2. Okay, so I combine these two, VS R2 plus VS R1 over R1 R2 equals V out times RL plus R3 over RL R2. Alright, now I can factor my VS out of the top there. So I have VS R1 plus R2 over R1 R2 equals V out RL plus R3 over RL R2. And my problem asked me to find VO over VS. So multiply both sides by 1 over VS. And then also multiply both sides by RL R2 over RL plus R3. The S's cancel. That cancels, that cancels, that cancels, that cancels. So I get R1 plus R2 times RL R2 over R1 R2 times RL plus R3 equals V out over Vs, and my R2's cancel. And so for my answer, VO over Vs equals RL over R1 times R1 plus R2 over RL plus RS. Let's see if that matches the answer I got here. Should be R2 plus R3. And yeah, I just copied that wrong. RL plus R3, R1 plus R2, RL plus... Yep, that looks good. All right.